Here's the neutron, proton, neutron. And this little particle right here called the pion is what's holding them together and associated with the strong force in the nucleus. Any questions on that? Repel protons because, why? They don't form a stable product. So you can't push electrons together. You try to push them together to form something new. They don't form anything new. That's why they repel each other. Repel means you don't form something stable. So chemistry.com is not about chemistry, it's about matchmaking. So in relationships in the future, not every relationship you get in, you're going to feel like you're forming a stable relationship. And some things repel, that is, they 3, why do elements with atomic numbers above 82 have no stable isotopes? You get to a point where the protons are just too repulsive. The protons want to push away, and no additional neutrons are going to stabilize the situation. So if we look up here on the overhead, you'll see here's lead. And you'll see lead has a stable isotope of 207. So here's Pb 207. Lead 207 is stable. Observationally stable. Now, what's after lead? Anybody know? 82 would be 83, right? That's going to be bismuth, Bi. And if you look up here on the overhead, you will see that there's no stable isotope. What does that mean, there's no stable isotope? Colorado.edu, and it is a simulator. And I got this activity, classroom, from the American Association of Chemistry Teachers. If you click download, you have 3 options. It's going to give you this, choose a game, this, where you have stability and the symbol, and then this, where you have the mass number and net charge. This is the one we're going to work on today. It looks like that. So I need somebody to come up here and so the atom, 1 proton. The American Association of Chemistry Teachers has this nice worksheet associated with the simulation. We're following the directions. And it says, after you added 1 proton to the nucleus of the atom, what element did you just create? Right, very good. It says hydrogen. So write that on your add a hydrogen, correction, a proton, and we created hydrogen. So first blank there would be hydrogen, and it is a positive ion. Heather put an electron into the circle and created a element, just as a review. Side of the nucleus and associated with like the proton or the neutron. And what it does, it works to hold the quarks together. So inside of the proton and the neutron, there are quarks, 2 or 3 of them, and it's what holds them together so that you have a proton and neutron. Otherwise, the quarks would want to come out and then you wouldn't have the characteristic proton or neutron. So the question for Bell Work 1 was what holds the proton and neutron together in the nucleus, and that's called the pion. Quiz on Thursday. Nice job, son. Elements larger than atomic number 26 need more neutrons in the nucleus to be stable. What do protons do? If you're of like charge, what do you do? What do electrons do because they're like charge? Hannah? You can see that it is unstable. Why is it unstable?
Because it doesn't run protons and neutrons.
Close, but no. What's happening between the proton and the neutron is called a, what's the bond? Strong force, right? But what's bonding between these 2 things? The pion, right?
Yeah.
So it's bonding between this one and it's bonding between this one. So it's going to have to make a choice. 50% of the time it's doing it with this one, 50% of the time it's doing it with that one. So it's going to lead to some instability compared to the last one. Take the neutron away. See how this is stable because of the pion strong force relationship? When you add another one, it's shaking because it doesn't have the ability to stay, I should say, bonded with more than one. It's kind of like juggling. Which one are you going to hold on to before you lose one? So that's the whole point, would be that there's more neutrons there, and it's hard for the strong force of the pion to bond between the neutron. Does hydrogen need a neutron? Hydrogen 1 is stable up there. What does that mean? It has no predictable death. Hydrogen 2 is stable. It has no predictable death. Which one's more stable? You can't really have more stable, right? It's either you're going to die or you're not going to die. So they both are stable. Which one's preferred? Hydrogen 1's preferred because it's more abundant. Why? Because neutrons are desired. Atoms want them. So there's a competition for them. Now hydrogen would like to have the neutron, but it's just not available. It's not available because of the percent abundance. Hydrogen's a fairly light gas. Does everybody see the 1-to-1 ratio right there? We have a 1-to-1 proton-neutron ratio. Does everybody see that? And it's not stable. Typically, until you get to element number 26, a 1-to-1 ratio is stable. Like carbon, 6 and 6 is stable. I'm going to show you that here in a second. This is 4 and 4. So this is an exception. It's kind of leading us in the direction to 26, where everything above 26 pretty much is unstable on a 1-to-1 ratio. Why is this unstable? We don't really know. But we do know that James Chadwick used beryllium in his experiment to discover what? Starts with an N. The neutron. Remember James Chadwick, neutron? Element, correction, an atom that is unstable. So we're going to let Kayla do that real quick. Kayla. You have to add protons, neutrons. And you're going to create an unstable atom.
So just one of each?
Okay, until it says unstable. We added the additional neutron, and we now have a stable beryllium atom. Carbon is stable, it has 6 and 6. Now let's add another neutron. That would be carbon 12 here. Add one more, that's carbon 13. And carbon 13 is stable. Carbon 14. Yeah. Yeah, carbon 14 is the unstable one we use for radioactive dating when we find new objects. We try to figure out how old they are. Now it only works for objects that are about 60,000 years old, because carbon has a half-life of around 5,700 years. So if you get objects that are really, really old, it doesn't work very well for that.
4 protons add neutrons and electrons to make a stable atom. What element did you create? How many protons, neutrons, and electrons does the atom have? And describe what you think is stable. Why you think it's stable.
Okay, let's go ahead and do that. Together. Starts with a P.
It's in my mind. What is it, Mr. Schneider?
Particle that bonds the proton and neutron together. Starts with a P.
Pion.
A pion.
Pion.
It's a pion.
That's what
Stable based on its proton to neutron ratio. And it's also unstable based on its electrons. It desires to have 3 electrons to balance these 3 protons. So this is, for nitrogen, it's very unstable. Because nitrogen is a non-metal, wants to gain electrons instead of lose them. If you came in contact with nitrogen 3 positive, it would be very aggressive to you. Because non-metals seek to gain electrons and not lose them. You see how it's lost them here? This is a loss. It says 3 positive. So it's very unstable electrically. All right, so note that. In the nucleus, the name of the particle.
Is it
Is it isotope?
It starts with a P.
It's like it's where it's like PL.
Starts with a P, and it's an ion.
Hold on, wait. Give us time.
Starts with a P, and it's an ion. Raise your hand when you got it. 5 points.
It's a 5-point question. Oh, crap.
It starts with a P. Starts with a P, and it's an ion.
Pion.
Pion, very good. So number 2, helium. Then it says, now before you remember we were talking about how this is unstable. Why is this unstable?
It has no neutrons.
It has no neutrons. That's exactly right we were talking. It has no neutrons, and you have no pion bond. Remember, the pion wants to bond the neutron. So this is unstable because protons do what? Raise your hand.
Ooh.
They repel. So good. Now, they don't look like fantastic. Protons have the same charge, they repel. Neutrons actually repel as well. Anything that's the same tends to repel. Not always, but typically.
But there's no neutrons there.
Right, that's why it's unstable.
But they're not repelling.
It's moving around, it is repel.
You gotta stay in the
It's pushing away from itself.
I would picture it going like
Close. Alright, add a neutron there. Add a neutron.
oh wait, it just says keep it.
I know, but you can see there, just adding 1 neutron stabilized helium. Based on what we just learned about the proton-neutron relationship with the pion, right? Why would helium be unstable without neutrons? Do protons attract or repel each other? Raise your hand, Ethan. Right, protons repel because they're of the same charge, right? They're the same charge. They're like electrons, they repel. So you're seeing repulsion right here. These 2 protons are repelling each other. So you have to have the neutrons there for the pion to bond them and keep them in the nucleus. Makes sense? Just 2 protons by themselves, unstable. What about the proton-proton relationship? Do protons attract each other?
No.
Andrew?
No.
Do protons repel each other? Ariel? Yes, protons do repel each other. And that's what's going on in the nucleus. Protons want to repel, right? It is a proton-neutron strong force. The pion is bonding them together. And you have to remember that they're moving around in the nucleus. The proton isn't staying in one place, the neutron's not staying in another place. They're moving around, and that moving around is what's creating that strong force interaction between the pion and the proton and neutron. Is that clear?
So like elements like iron, or what?
You wouldn't see an element with 2 protons like helium and no neutrons because the protons would repel each other.
Right. Would it expand the element, or how would that work?
They would break apart. It would be unstable. You'll never see an H2E. He2 is just too unstable because of the proton repulsion. So it really goes back to that as far as the proof. You want to see the proof, just look up helium with just 2 protons. It's very unstable. We're going to show you that today. Nick?
Helium.
Helium. You see that? That's number 2.
I see it.
So write number 2 there. That would be hydrogen and helium.
So it's fine. Thank you, Mr. Stein.
So good. The second one makes it unstable. Nice job, Alex. Because of what? Starts with the P.
The amount of protons there is.
What do you-
On the periodic table.
Right, so as Alex stating, you are adding a new element, or making a new element every time you add a proton. You see how it's went from oxygen to fluorine? Now she's going to go to neon. So what does the proton control?
The atomic structure.
The element